This animation on incrementing and decrementing in thousands from any number will make use of base 10 materials. If you're not familiar with the relationships between the different pieces, then we recommend you watch the introductory video first. There is a link to it in the video description. As you watch the animation, try to figure out the total value of the collection. In today's collection, we'll be using base 10 materials. The small cube will have a value of 1. You'll need to keep a running total by adding the value of the new items to the items you've already seen. The new items will appear quite quickly. Someone could record the new total each time, and at the end, you could explore any patterns and relationships you see. First, figure out the total value of our starting point. Remember, the small cube has a value of 1. The value is 1,243. Now figure out the running total as more is added each time. Remember, your starting value is 1,243. Ready? What was the total value of the collection? You may wish to pause the video and compare your ideas before watching the next part. Let's slow that down and check. You can count along together as the items appear. 1,243, 2,243, 3,243, 4,243, 5,243, 6,243. The total value of the collection was 6,243. Here are a few questions about what you saw. Pause the video if you need more thinking time before the next question. How many thousands are in the whole of 6,243? There are 6 thousands in 6,243. You can see the thousands represented by the large blue cubes here. How many hundreds are in the whole of 6,243? There are 62 hundreds in 6,243. We'll explain why in the next part of the video, but pause it here to see if you can explain the answer in your own words. There were 62 hundreds in 6,243. I know that in 1,000 there are 10 hundreds. 100, 200, 300, 400, 500, 600, 700, 800, 900, 10 hundreds. 10 hundreds is the same as 1,000. Then in 2,000 there must be 20 hundreds. In 3,000 there are 30 hundreds. In 4,000 there are 40 hundreds. In 5,000 there are 50 hundreds. In 6,000 there are 60 hundreds. Then there were also 2 extra hundreds in 243. So altogether there are 62 hundreds in the whole of 6,243. If your answer to this question was 200, this isn't quite right. Here's why. The question was asking how many hundreds are in the whole of 6,243. This means that it's asking if I made the number trying to use just the flats, which today are worth 100, how many of these would I be able to use? We saw the result of this in the last animation. If your answer was 200, then you were probably thinking about the digit 2 in the numeral 6,243. You're correct that the digit 2 is in the hundreds position, and therefore the digit 2 has a value of 200. However, this is a slightly different question to the one that was asked. How much more do you need to add to 6,243 to get to 6,250? I know that 3 plus 7 equals 10. Watch the small cubes being added to the ones. Therefore, I know that 43 plus 7 equals 50. So 6,243 plus 7 equals 6,250. Therefore, I need 7 more to get from 6,243 to 6,250. How much do you need to subtract from 6,243 to get to 6,200? We can see that 6,243 is made up from 6,200 and 43. So if I subtract 43 from 6,243, I'm left with 6,200. You can record this as an equation. 6,243 minus 43 equals 6,200. What is 6,243 rounded to the nearest multiple of 100? The multiples of 100 on either side of 6,243 are 6,200 and 6,300. 6,243 is 243 away from 6,200, but it is 757 away from 6,300. So 6,243 is closer to 6,200 than 6,300. Therefore 6,243 rounded to the nearest multiple of 100 is 6,200. What patterns and relationships did you notice, and why did these occur? Take a moment to think about these questions when you see the full sequence again. After you've had some thinking time, you can share, compare, and discuss your ideas with a partner, group, or the whole class.